Okay, now we should be good to go. Um, 1.8 is inverses, and I will tell you that this is definitely one we're going to want to spend a little bit of time reviewing as we go. There is a lot to it, but the underlying theme of inverses will not change. If you notice, we got a lot of learning goals today because we're going to verify that things are inverses of each other. We're going to be able to graph inverses, and we're going to be able to find them from given a function, both by that and the graph. Now, we have already learned how to do composition. So if we look at these two functions up here, if f of x equals x plus 300 and g of x equals x minus 300, if we look at the composition of those, and these are pretty easy, quick compositions to do, right? Okay, so again, it is always start with the first function, write it out but put a parentheses wherever there's an x. X plus 300 would be f of x. Plug in the second function everywhere we had a parentheses, which would be x minus 300, and clean it up. Well, x minus 300 plus 300, what do we get? X. Yeah, the 300 minus 300 is 0, but we have an x left over, right? So this equals x. Notice on the other one I switched the order, which says write out g, x minus 300, fill in f, x plus 300, and we got the same thing going on, don't we? Minus 300 and plus 300 is 0, and we're left with just x. Well, these are very easy, straightforward, but what you're seeing are inverses of each other. They're undoing what the other function is doing. Do you see how one of them is adding 300 and the other one is subtracting 300? And what is happening is we're undoing each other. Those are what's called inverses. What you're seeing is a little preview to our verification of that. Is because if they undo what the other one's doing, you should get back to just the plain old variable at the end. So that's what an inverse function is. Thank you. You too. It's saying this: if they are inverses of each other, when I do the composition, order will not matter, which normally it does, right? But order will not matter because they're going to undo each other's function, and f of g would equal x, and also g of f will equal x. Okay, so they undo each other, and again we can write it that way, or as we saw it on the last page here, f of g of x equals x, and g of f of x equals x. And if that happens, they're what's called inverses of each other. The notation that you are going to see, if it is true that they are inverses of each other, is this little, it looks like an exponent of a -1, but it's a mathematical symbol indicating inverse. So we would read this as f inverse. And so writing out the same thing that I did up here, but with our inverse notation, it's saying that if we were to do the f of the inverse of x, we would get x, or the other way around, the inverse of f of x, we would still get x. So plugging one into the other, same thing I wrote above, except for with the inverse symbol. Okay? So one of the things you are going to be asked to do is to verify inverses. Well, guys, that's what you did 2 slides ago. You verified it. It's basically a 3-step process. Okay? So given the functions 4x minus 7 and then g of x, which I think is missing on your note sheet here, g of x equals x plus 7 over 4, when it asks us to verify, I would equivalent this to like geometry proofs. Prove it. I'm telling you right now, they are inverses. You prove it, and the way you prove it is a 3-step process. Step number 1, show the plugging in process. So show the setup. And by setup, I mean show doing f of g. Okay? So when I show this, I should write out f, plug in g. Step 2, cleanup. Now, a lot of times this will be, we don't have that many complex ones. So a lot of times it'll take us like just one line or maybe 2 lines of cleanup. But there's usually not a lot of cleanup to do. With that being said, you can only do one step at a time. So the first step, if I were to follow my order of operations while I'm cleaning this up, would be taking care of the fact that we're multiplying by 4 and dividing by 4, and those would be opposites of each other, right? So multiplying by 4, dividing by 4 would be gone, and I would be left with x plus 7 minus 7. Okay, well then plus 7 minus 7 would be gone, and that leads us to step number 3, show it equals x. This equals x. Done. We have verified that they are inverses of each other. If I don't get to a plain old x at that last line, I haven't verified anything. Because if they're inverses, we should have an x at the end. So if nothing else, if you don't know how to do the cleanup part of it, show the setup, show an x at the end, at least you got half of it, right? Okay? Same thing the other direction. Show our setup. Show our, oh, I didn't do the whole setup here. 4x minus 7. Well, part of the cleanup process is you have to understand algebraically what order to do things in. In this one, actually, what's the first thing that I should do? Does anyone know? Yeah, the negative 7 plus 7. That's actually what I would do first. Negative 7 plus 7 is gone, leaving me with 4x over 4. And then my 4's cancel, leaving me with just a plain x. Done. Verified. So again, I will tell you, for whatever reason, this is one of the questions that people tend to forget how to do when we get to our exam. Please make sure that you go back and look at this. Understand the 3 things that I'm looking for. Setup, cleanup, equals x at the end. Every time. Okay? All right. Finding inverses. Last time I told you what the inverses were. This time we need to go find what the inverses are. I nicely have written out for you on the side kind of the steps to follow each time. We're going to look at a couple different variations of equations and how we go about solving those. We'll start with the basic one. Step number 1 may or may not need to be something we do, but if they hand us a function, it's easiest if we just rewrite instead of f of x. Remember how f of x and y are like the same thing? Okay, just rewrite the equation with y there instead of f of x. So it would be y equals 7x minus 5. Because that makes then the next step easier. Now I'm going to go through and rewrite the equation again and swap out all my letters, wherever they are, however many there are. If it was a y, it becomes an x. If it was an x, it becomes a y. And then we solve for y. So go find the variable y. I want to get this all by itself. At the end of this, I want it to say y equals. So I want to get rid of all of the things that are around it. So we have to remember how to solve an equation, right? So if I want this by itself, first thing I would do is add 5 to both sides. Then I would divide by 7. Please make sure you understand you're dividing everything by 7. Now you could go through and individually divide everything by 7 if you want to. I will just leave it all over 7. Okay. And then the last thing to just indicate our answer that we are looking at the inverse of our original function is I will replace y with the inverse symbol. F inverse, and that's just rewriting this. Questions? All right, we're going to do this one a couple times just to see some of the other variations of equations that we could do to find our inverse. Next one, f of x equals 4x cubed minus 1. Step number 1, rewrite the equation, but write it as y equals instead of f of x equals. Step 2, we're going to rewrite it one more time, but this time I'm going to swap all my letters. So now it will become x equals 4y cubed minus 1. And lastly, we will solve for y. Again, this is what I'm trying to get by itself. This is why we're having these conversations, is to remind ourselves of order of operations. Remember, please excuse my dear Aunt Sally, and how you start at the end and work your way backwards, right, to undo all of that, to solve. So we have 3 things going on by that y. We have a 4, we have a cubed, we have a minus 1, and we have to remember the correct order in which to get rid of those to get to our correct inverse. What should I get rid of first? Minus 1, you got it. Remember, we always will undo those pluses and minuses first. And then this is where people, again, will kind of jump the gun. Now what should I do? Divide first. We're going to divide first. Because, and please excuse my dear Aunt Sally, remember we're kind of undoing this, where these go together and these go together, right? We would undo any addition or subtraction, undo any multiply, divide, then we're going to undo any of our exponents here. So the next thing I would do is divide by 4. I would say jumping the gun on undoing the y cubed part of it is definitely a common mistake. Remember, we're going to do the opposite of this exponent. So if it is y cubed, we cube root, right? My root should match the exponent. If that had been a y to the 4th, it would be a 4th root. If it were a y squared, a square root. So at this point, I would cube root both sides. All of that is inside your cube root. And then just writing my answer with the correct notation. Instead of y, I'm writing it as the inverse of x. Okay, the first 2 are pretty, I think a lot of us would have been able to get through those with or without any of my help. The last one, please make sure that you take really good notes when we run into these fraction ones. The fraction ones take a little bit more work, and there's one little step in there, 2 little steps in there, that you may not have recognized to do to be able to solve for y. We'll start this the same. So our function this time, f of x equals x plus 1 over x minus 5. You will notice that off to the side it does indicate that this is a function as long as x does not equal 5. Okay. I start by just writing this as y equals x plus 1 over x plus, minus 5. Swap all my letters. We've got a couple places of x's this time. So it'll be x equals y plus 1 over y minus 5. So on this, you will notice that I have multiple y's. There's not just one y in there, right? So it's a little bit more tricky on the how do I get it to at the end just say 1y equals something. So this is how it's going to work every single time. The first thing you're going to do is multiply by the denominator. So I'm going to multiply both sides by y minus 5 just to get that y minus 5 out of there. When I do that, multiplying by y minus 5 and dividing by y minus 5 are going to simplify, leaving me with just the y plus 1 on the right-hand side. On the left-hand side, make sure that you distribute that x through there. Giving us an xy minus 5x. Okay. Now I'm going to collect all my y's on one side, and I'm going to collect all my non-y's on the other side. Okay. So we're going to move y's to same side, non-y's to other side. Okay, well that's 2 things for us on this one. Things that have y's would be here, and I need to move them to the same side. There is not a right or wrong answer at this point. In this particular problem, I'm going to move the y's to the left-hand side, which means this xy right here is going to stay where it's at. This y I'm going to subtract over. These are not like terms. X, y, and y are not like terms, so it's just going to say minus y there. Okay, and then I'm going to get the non-y's to the left-hand side, which means I would add this 5x to the other side. Again, not like terms here. So we'd be at this point right now. All right, this is the step that a lot of people will forget. Now I have to take out the y GCF. Both of these terms have a y in them because that's how I moved everything, right? So take out your y GCF. So I'm going to factor a y out of each of these terms. When I factor a y out of each of these terms, remember that it's like we're dividing each of these by y is kind of what it means when I'm factoring out the y. This would just be an x. Y over y is 1. Okay, one more step. Divide by what's next to y. Divide to get that y alone. So I would divide both sides by x minus 1. And we would finally have, move down here, y equals 5x plus 1 over x minus 1. Which, replacing that with f inverse, questions? Hopefully you took good notes for yourself. That one's a little tricky. So, all right. Just like we were in our equations, switching all of our x's and y's, in our graph, that's what's happening on our inverses as well. So if I gave you a table of points or you saw points in a picture for the function f, f's inverse would be found by taking all of the x's and y's and flip-flopping those, or moving my x's to the y column and my y's to the x column. Or for each individual point, if 1 comma negative 2 is on f of x, then negative 2 comma 1 is on f inverse. That's the underlying theme of inverses, is flipping x's and y's. Not every function has an inverse function though. So when we start talking about like looking at the picture and such, you will start hearing about this thing that is called the horizontal line test. Now, we've heard a line test before, and it was called our vertical line test, and that was to see if if something was a function. To see if a function has an inverse function, we use this thing called the horizontal line test. If I can run a horizontal line through my graph and hit my graph at more than one point, which I do here, right? That means it fails the horizontal line test. There is no inverse function that exists for that graph. Just to give you a little preview of what that means, if I were to have taken all of the ordered pairs in this picture and I flipped all of their x's and y's, the graph would have ended up looking like this, which is a graph, but it's not a function, right? It is not a function because this would fail your vertical line test. If I can draw those horizontal lines through here and never hit my graph at more than one place, that means that an inverse function exists. And when I switch the x's and y's and regraph that, the inverse would also be a function. And I know we haven't really talked about how to graph this, but the inverse of that would have looked like this, and that passes your vertical line test. So it's inverse, just literally swapping the x's and y's. The result is a function. Questions on any of that? Okay, now your book talks about how it is reflected over the line y equals x. So I want to show you that. Yes, an inverse and its function are reflected over the line y equals x of each other, which again maybe makes sense because y equals x, we're flip-flopping our y's and x's, right? But I think it is a lot easier to do this part of it, interchange your x and y of your point to get the inverse graph than it is to try to reflect over the line y equals x. That's not as easy as it looks visually to do by yourself in a graph. Because you kind of have to like count diagonally. It's not as easy to do as it is to just flip your x and y in your ordered pair and regraph those points. Okay? So yes, this is how your book describes graphing an inverse. I would say what I would do is look at the ordered pair. Notice I would just flip-flop the first and second number in those ordered pairs and regraph is a way easier way to attack graphing an inverse. Okay? So, there we go. How do we graph an inverse? You're going to start by finding nice points, okay? Nice points meaning I can see exactly what that ordered pair would be. I'm going to flip the x and y. And I'm going to regraph. Okay? So they have three nice points identified for us in this picture. To graph the inverse of this picture, I would take each of these points. I would flip-flop that ordered pair. So the ordered pair -3, -2 would become the ordered pair -2, -3, and I would go put this dot in my picture. -2, -3, which would end up right there. And I would do that for all of the nice points in our picture, that the point -1, 0 would become the point 0, -1. 0, -1 would be graphed right here. And lastly, 4, 2 would become the point 2, 4 when I flip-flop those x's and y's, and 2, 4 is graphed right here. And then I just connect the dots. Maybe that should be a step here too. Connect the dots. And if we were to consider the line y equals x, which is the one that goes through the origin diagonally here, across my whole graph, can you see that that was flipped over that line? Okay. I just don't think that's an easy way to graph it. Just take each point, flip your ordered pair, regraph that dot, that's your inverse. Okay. Sometimes they won't give us the picture to start with. We have to get the picture to start with. So let's talk about this one here. Find the inverse of f of x equals x squared plus 1. We know how to graph x squared plus 1. Rewind to your transformations chapter, right? Now, before you draw anything, let's talk about this real quick. In our transformations chapter, I would have told you to take this, right, and do your parent function. Square each of those, we'd get 4, 1, 0, 1, 4. Okay, don't draw anything on your picture yet because I'm going to erase some of this. I would have taken each of these dots, -2, 1, 2, 3, 4, 1, 1, 0, 0, 1, 1, and 2, 4. And I would have moved each of those up 1, because that's my transformation, right? Up 1, up 1, up 1, up 1. But did you notice that there was a little restriction that followed it? And it said that we're actually only using the ones where x is bigger than or equal to 0. Well, these are not bigger than or equal to 0, are they? Here's 0, here's bigger than 0. We're only using these 3 dots. Why do you think they included that in this problem? Anyone have any guesses? Why did they restrict the domain? Because they're asking us to do the inverse, right? And if I were to graph that as is, that parabola, does it have an inverse function? No, because it fails that horizontal line test. But if I erase the dots that are less than 0 here, and I only use the ones that are bigger than 0, does that now have an inverse function? Yes. Okay. Now you can continue to use your table, which is not going to help us since first of all it includes other dots here, and it also is not moved up 1. Or we can just go to our picture and identify what each of those points are. So I'm going to get rid of this because I don't want to confuse us. We have the points 0, 1, 1, 2, and let's see, 2, 5. And so I am supposed to now take each ordered pair and flip the x's and y's, which I probably should have written on this side here. Flip the x's and y's and regraph those. So if I look at the point 0, 1, I would flip that and it would become 1, 0. Well, 1, 0 would be located right here. And if I took the point 1, 2 and I flipped that ordered pair, it would become 2, 1. 2, 1 would be right here. And this one right here would become 5, 2, 1, 2, 3, 4, 5, up 2, and graph through those. Questions? Okay, very quickly connecting all of this. Does that end up looking like the inverse? It does. If I were to draw in that line y equals x, it was flipped over that. If I were to go back and find the inverse function of this, I could have done that. Remember, our way of doing that is if I were to, oh, this is a bad one to show this on, but that's okay. We'll show it anyway. I would have solved by subtracting 1 and square rooting. And does that look like the graph of the square root of x moved to the right 1? Remember our transformations? Yes, the square root of graph. X moved to the right 1. Okay, so we can see the overlap there. All right. This is one of the more challenging ones to do algebraically. I would like you to try this one without me talking through it. If you need to go back to your notes, follow the steps in your notes. If you think you can do it without, do it without. Step number 1, write down your equation, but make it y equals instead of f of x equals. Step 2, exchange all your letters. Distribute. Ooh, I think so. I actually haven't done this yet. It looks good, yeah. All right, like I said, this is going to be our challenging one, right? Because it's got a few more steps to it than all the rest of them. I would have started by, instead of having the f of x here, say y equals. So that it is more obvious when I go to do this next step, rewriting, changing all my letters. Okay. Job one, get that denominator out of there. That's usually the first job if we ever see a fraction, is we want that denominator out of there. Multiply both sides by y minus 2. Now remember, on the right-hand side, that is just going to cancel, right? It's not going to impact the numerator at all. And then on the left-hand side, you want to distribute through. All our y's onto one side, all our x's onto the other side. So I would subtract this y over. I would add this 2x to the other side because it's not a y. Then this is the one that a lot of times catches people in this process because it's this little trick to solving for y. Factor out the GCF. They both have a y. Pull that out of each of those terms. You should still have two terms left. We started with two terms. This one is left with an x. This one is left with a 1. And lastly, divide by that. Y equals 2x plus 4 over x minus 1, or f inverse equals. Questions on that? All right. We are going to skip and go to your assignment.